Good morning, friends. In this video, we are going to see the fresh air calculation for a high-rise building. If we do the fresh air calculation for a simple room like 10 by 10 feet, we can't understand the difficulties of air balancing, positive, negative pressure concept. So we will do the calculation for the complete floor rooms. So you will get very clear idea about FAHU calculation. In this floor, you can see different rooms are there. For example, director room, open office area, reception area, meeting room, head of department. So we are going to do the calculation for all the rooms. And important thing is here you can see the electrical room and also the storage room. So these are the rooms don't need the fresh air. So when we do the calculation, we can avoid all these rooms. And additionally, if you see here, you have the soft area, you have the HS lift area, VIP lift, and different lifts are there like this one, and also we have the stair area. So again we don't need the fresh air calculation for this type of rooms also, so that also we can avoid. So avoiding all this room, we have the balance room, like wherever the manpower or the human beings are present, there we have to maintain the IAQ, indoor air quality. For that we have to continuously provide the fresh air, and we will see the full floor of this floor calculation in this video. So starting from the director room, you have to find out the indoor area of the director room. For example, you can measure the indoor area from the internal size. For example, like this. So like this, you can measure the internal area. And when you measure the internal area, you have to avoid this permanent structure like this column and any other permanent structures are there inside the room. That one you can avoid when you measure the internal area. For this one, internal area, you need to avoid the toilet also, and also secretary room. We will do the fresh air calculation separately for the secretary room. So after measuring the area for the director room, so you can go to the Excel file. Can provide that value 42.91 meter square is the indoor area, and also the ceiling height, I mean the height inside the room, that ceiling height is 4.7 meter for this level. And coming to this occupancy category, already all the ASHRAE 62.1 values are linked here. So if you just click on this one, so you can find the different rooms like a hotel room, motel room, office building, miscellaneous spaces, public assembly, residential area, retail area. So all this value already I linked here. So the backup of this document is from ASHRAE 62.1. This table you can see. So this is already linked here. So in our case now this is the office building. So office building, if you see here, I am going to click the office building here, and after going this one, we have to go for the subcategory, because in the office building there will be multiple category will be there, like reception will be there, office space will be there, break room will be there. So different subcategory will come. For that again you can click this one. You can see the break room, main entry lobbies, and storage rooms, office space, reception area, telephone data entry. So now our case is the director office. So director office, I'm going to choose the office space. So after doing that one, you can see this person per 100 meter square. So they are asking the occupancy rate. So how to we need to know the number of people to find out the fresh air requirement. So if you go to this category, like if you go to this drawing, you can see in the office space there is one permanent seating is there, and two seat for the visitors, and also there are some furniture which is given for the visitors to sit. And this is the one method to count the number of seat, and based on that you can choose the number of people for the calculation. And another method we have, that one you can go to ASHRAE 62.1, and from the ASHRAE 62.1 you can measure the number of people. For example, this is it, ASHRAE 62.1, table 6.2.2.1. They have given the minimum ventilation rate, that means the fresh air requirement. So here you can see that the value they have given occupancy density for 100 meter square, how much people we have to consider for the calculation. So here you can see the office building also. So in the office building here, if you go down, you can see the office spaces here. Here it is office spaces. So for the 100 meter square, we have to consider 5 people for the calculation. So as I told, you can follow the ASHRAE 62.1 for the number of people counting. Otherwise, you can follow the architectural seating method to find out the number of seat and number of people like that. So in this video, I'm going to follow the number of people based on the ASHRAE 62.1. And after that, the number of people, I have the formula here, because here the concept is for the 100 meter square, It is 5 people. So in our case 42.91 meter square. So we have the interpolation formula here. It will automatically come. The value automatically come. And coming to the liter per second person. So already you can see the formula. It is already linked here. So you don't need to enter any value. This value will automatically come from the ASHRAE 62.1. And coming to the actually here we have two concepts: liter per second per person, liter per second per meter square. So if you go to the ASHRAE and here you can see for the office space. So it is 5 CFM per person. You can see the unit here, 5 CFM per person. And if you go to liter per second per person, it is 2.5 liter per second per person. And CFM for feet square. So we need to find out the number of people as well as the area also. So 0.06 CFM per feet square. And also if you make it in the liter per second, this is what I am following for this Excel file. That will be 0.3 liter per second per meter square. So in our Excel file, it is the in meter square and also in liter per second. So we have to follow 2.5 liter per second per person and 0.3 liter per second for meter square. Now let's go to the Excel file. You can see the same answer here, 2.5 liter per second per person and 0.3 liter per second for meter square. After that, after adding these two value, you will get you have the formula number of people. You can see the formula here. J8 into I8, that means the number of people into the 2.5 liter per second, and also 0.3 liter per second per meter square into what is the area we have. So we are finally getting 18 liter per second. So from this one, you can see the yellow color one, that is the fresh air requirement for that room. And in this one, for example, you can see the second one. So for this one we will discuss now. So 7 liter per second, 7 liter per second is the required fresh air for the small room. But I have considered 50 liter per second because the minimum value in this Excel we have set to consider the minimum fresh air value was 50 liter per second because 7 liter per second is very small. So similarly, whatever the value we get here, we are round off to the nearest one. For example, here 18 I round off to 20. Here I got 124, I got round off to 125. So similarly, I got the fresh air value here. The next one is the exhaust air. So exhaust air, what I did is I want to maintain the positive pressure throughout the floor. So for each and every room I am considering like whatever the air supply like a fresher 10% lower than that one. That means 90% I consider as a return. So whatever the value I get here, I will multiply with 0.9. That means 90% is a return. So here 80 liter per second will come as a return value. Now we finish the director room. The next one is the secretary room. Secretary room 404-02. And after measuring the area of the secretary room, I added the value here 16.29. This is secretary room. And the ceiling height is same. There is no change in the ceiling height. This is the office building. And also subspace, also office space. And here the number of people we have to find out. So as I told you, ASHRAE 62.1 for the office space for the 100 meters square, it is 5 people only. So that's why for this area, also the next one is the open office. Then there also I entered the 5 people. So the next one number of people I have to find out. Again, as I told you, there is an interpolation. So 100 meters square, it is 5 people. So this is around 16.29. So I consider 1 people for the secretary room. And also these values are same, 2.5 liter per second, because this is the main category and subcategory is same. So this value will not change. It will be still 2.5, 0.3. And the total fresh air requirement is 7. And as I told you, I round off to the minimum value of 15 liter per second. That is the fresh air. And in the return year, 90% I have considered. 90% of the 15 liter per second. That is 14 liter per second. So that is considered as the return year. And after that, we have the open office area. So if you go to the drawing, you can see this open office area. This area for the calculation, what I have considered is, so here we have the corridor and here we have the reception. So for this calculation, I have considered the area till this area like this. I have avoided the permanent structure column. So like this, I have considered the area for the open office area, and this area I have entered in the Excel file. So you can see here. So this area I considered here, and the ceiling height is same. So main category, subcategory is the office building. It consider office building. It is not the change. It is a different area. So again, for 100 meters square, 5 people. I have done the interpolation, so we can get the 4 people. And 2.5, 0.3, there is no change. And finally, the answer for the fresh air, we are getting 35. So this is a 35 round of value. And coming to the exhaust, 90% of the fresh air I have considered as the exhaust. You can see I have multiplied with 0.9. This answer. So 32.31 liter per second is the exhaust air. So the next one we have the reception. So reception launch, you can see here. For this reception area, I have measured the same like area and I entered the Excel file. Here one small difference is there. If you go to the ASHRAE 62.1, so here you can see the reception area which is comes in the office building. Here the number of people for 100 meters square is very high. That is 30 people we have to consider. And coming to the flow rate, in the flow rate there is no change. Full office building we follow the same flow rate. That is 2.5 liter per second for one person and 0.6 liter per second for meter square. So this is for the break room, and balance all room you can see here this is only 0.3 liter per second for 1 meter square and 2.5 liter per second for one person. And these people, the number of people is very high, like 30. Earlier it was 5 for the office space. So these changes we have to implement in our Excel file. For example, if you go to the reception area, here I have consider like office building main category and subcategory. Here if you see here, we have the reception per area. So this one we have to change to reception per area. So the value will change automatically. But here the number of people we have to enter. So number of people based on the ASHRAE 62.1 it is 30. So this 30 I have added here. And here we have the interpolation. The same formula it will do the interpolation. So the answer will be 35 because we have 117.83 meter square and 0.2 and 0.3 there is no change. It automatically comes from the Excel file only. And the total flow rate based on the calculation it is 124 liter per second. And as I told you, we are going to round up to nearest one, that is 125 liter per second fresh air, and the exhaust air is 90% of the fresh air. So now we finished these four rooms, open office area, director room, secretary and reception lounge. So next one in the bottom side, you can see the head of department. There are two head of departments we have. So if you have both the rooms with the same name, you can provide these architectural room numbers like 423 and 423, 44 for clear understanding. So now for the next one, head of department 423 and head of department 424, which again I have mentioned the area, room height is same and it comes under office building. The both building comes under office building. And the subcategory it is office space only, there is no change. And for office room you know that for 100 meter square we have to consider 5 people only based on the ASHRAE 62.1 that I showed you now. So here it is 14.36 meter square, so automatically this formula will consider the answer. And here this 2.5.3 there is no change, this answer will be remain same. And coming to the answer it is 6 liter per second, say the total value, but as I told you minimum value of 15 I have considered. So next one is the HR office. So you can see in the drawing this two head of department is very easy to find out. So the next one is the HR department office. So you can go here. The area is very big here. So another important thing here is actually here what I have done. Here we have one corridor area also. So this is like a open area, head of department. This one is a open area. So I have considered one imaginary boundary. So that means I have considered till this level as a HR office and balance this area. What you see here, this one I have considered in the corridor. Okay, so now HR department office I have mentioned the area 79 and the others are same, there is no change. We can follow the same like office building, but this office space is the this is the office space you have to change. And this is 5 number and 2.5.3 there is no change. So 34 is the final answer. I have round up to 35. So like this there are other rooms are there that you can follow the same concept. Assistant room, director room. So assistant room I will change to office one. Then director room I have entered the same area. Then meeting room, so head of department room, then quiet room, then meeting room, like this one by one we can enter. So what make the changes here is the toilet. So all these rooms will come under same category. You have to main in the main category office building, subcategory office space. And coming to the toilet, there will be one big changes will be there. That is a new for this one. So first toilet in director room. So let me go to this side. So you can see the director room here. There is one toilet. Okay, so if you zoom this one, you can see there is one water closet is located inside. Only one water closet. You can see one water closet is inside. So for the water closet, we can find out the ventilation value from ASHRAE 62.1. So this ASHRAE 62.1 table 6.5 is for the minimum exhaust rate. This table we should not use for the fresh air calculation. Only for the exhaust we have to follow this one. And here you can see the toilet public, because we are doing the office building. So this is the public area. So toilet public, we can see two value. One is a 25 liter per second and another one is a 35 liter per second. So we need to understand what is the difference between these two. So for this you can refer these notes number D and H. First note number D, what they have mentioned, this value, the rate is per water closet, urinal or both. So it can be when you enter to the toilet, it can be water closet or urinal or both can be there. And provide the higher rate where the periods are where the periods of heavy use are expected. Okay, so we can expect like one time all people will enter into the toilet based on some application, and they will utilize the toilet continuously, so like a heavy use. So that time we can go with the 35, like it's mainly simply saying it's a continuous use and a heavy use. So for other normal application like office building, we cannot expect that much crowd usage for the toilet. So that type of thing we can go with 25 liter per second. That is sufficient for the office building and application. So 25 liter per second we will choose for the toilet here. And going to this one now, for this toilet, the toilet in director room, only one toilet we have. So what we have to do, the main category is office building, but the subcategory went by extraction. That means we are extracting the air from the toilet, we are taking we are throwing it outside one. So now here what we are going to do, this all I put 0 0 0, this is not required. So coming to this last one, here you can see there are some special column we have. So if you go to top side, you can see washroom exhaust rate 25 liter per second for one unit. That means for the one water closet we have to consider 25 liter per second. If you have 5 water closet in the same toilet, 5 into 25 you have to consider. And exhaust rate, that is given in liter per second per meter square. This two is for the exhaust. So sometime some rooms we have, for example like locker room, you can go to this one, you can see here we have the locker room. So this locker room also will be placed in the toilet area, somewhere side by side. So if you have the locker room or shower room like this, for example let's say that we have the locker room that is used for the athletic purpose, and they have given 2.5. so what they have given, so if you have the locker room for meter square you have to consider 2.5 liter per second. If you go up you can see 2.5 liter per second. Suppose you have one locker room like this, which is a 10 by 10, so 100 meter square. So we have to consider 100 meter square what is the flow rate. Okay, so that is the reason in this Excel file we have added both the information. Like suppose in your project, if you have only the water closet, you have consider number of water closet, and in the exhaust rate, if you have locker rooms and those type of room, per meter square what is the flow rate. So both options you have, you can enter here. And additionally, if your project has the air change per hour value, then directly you can provide air change per hour value. So now going down, we have only one water closet in our project, so I have entered only one water closet. So only one water closet, the value will come automatically 25 liter per second. So 25 liter per second is for the exhaust. To compensate the exhaust air, we have to provide the fresh air. So 90% of the exhaust air I will consider in the fresh air, because here the reason is this is the toilet room. So the toilet room we cannot provide the positive ventilation. Positive ventilation means if you provide the positive ventilation to any toilet or any area, what will happen, the smell or the dust which will not enter into the toilet room if you maintain positive ventilation here. Okay, so the outside contents will not enter into the room if you have the positive. So if you say like the toilet, if I maintain positive, what will happen, the toilet smell will be still there, it will not go outside. So that is the reason toilet we will enter the negative ventilation. So what will happen, so but one more important thing, if you maintain the negative ventilation here, to compensate the negative ventilation, this fresh air has to enter here. For example, here toilet I need 25 liter per second, so I told you 23 liter per second fresh air I have to provide. So this fresh air, how we can provide this fresh air, you don't need to directly drop inside the toilet. To compensate the exhaust here, you have to provide 23 liter per second, that you can provide in the director room. Okay, so how, but what important thing you have to provide, so this is your toilet door, so this is your toilet frame. So what you can provide, you have to provide the undercut, you have to provide some undercut in the bottom. So you can provide at least 1 centimeter undercut. So what will happen when the exhaust fan throw the air outside, to compensate the exhaust fan through the undercut, it will take the fresh air from the nearby room. Okay, so in this case it will take the fresh air from the director room. So the fresh air will enter into the toilet to compensate the 25 liter per second. So that is the reason some people provide the undercut, some people provide the lower, also lower in the door. So there are two options how we can follow. So the door undercut is the cost effective method, you can follow that. So here I have provided 25 liter per second as a exhaust. 23 is the 90 percentage of the exhaust is a fresh air. So because of the negative ventilation, and same will duplicated here also automatically in the formula. We don't need to make any changes. And next one is the next building is the next toilet is the toilet near corridor 11. So if you go to the drawing, toilet near corridor 11, you can see the corridor area here. So in the corridor area, we have near to the corridor 4-11, we have three toilet. This is a ADA toilet. For the here there are three toilets are there, like 1, 2 and 3. So three water closet they have given. Okay, so these three water closet we have to consider in the calculation. For example, if you go here, the toilet near corridor 11, as I told you, all these 0, 0, 0 we have to follow. And come to this one, I have mentioned here three water closets. So I have entered three number here. So 3 into 25, 75 liter per second, and pressure is 90 percentage of the exhaust air, that is 68. So the same will be duplicated here as a default. And next one, so that is also done. We have the pantry. Pantry near electrical room. So if you go to the drawing, you can see we have one pantry here, and this is very near to the electrical room. So this electrical room, you can mention the name 4-7 electrical room, and here only we have one kitchen sink and one small one electric. In the office building normally there will not be heavy cooking. It's like a small micro oven will be there, one coffee maker will be there. So very small amount of cooking operation will happening in the office room. So the ASHRAE 62.1 table, you can see that we have different type of kitchen. One is the kitchen, that is the small kitchen, very small kitchen, and the kitchens for the commercial. So the residential kitchen. So in our office building, the kitchen is very small. As I told you, we have only the micro oven as well as one small coffee maker type of arrangement. So I can consider kitchen because of the small area. So I will consider 1.5 liter per second per meter square. Okay, for this kitchen area. So what we have to do, we have to go to this one, this office building. The location is pantry near electrical room. So moving further, you can see I have entered 1.5. So because here if you go up, as I told you, this is a liter per second per meter square. So that is the reason this is liter per second per meter square. So that is the reason I have entered here 1.5 liter per second per meter square. Okay, so we have to consider this value, and you have to provide the remarks also for the reviewer clear understanding. So 1.5 liter per second meter square, and this side what I have entered, I have entered the area 3.84 meter square, that is the area. So the software will automatically take the answer considering the area. But as I told you, here the area is very small. That's why I have considered the minimum flow rate of 15 liter per second, because the main thing is for 1 meter square we have, as per ASHRAE, 1.5 liter per second. Our case it is 3.85 meter square. So the answer will be only 5.775 liter per second. So the value is very low. So I have considered the minimum value of 15 for this exercise. And going to the next one, you can see the toilet near director room. So we can see the toilet near director room from the drawing. So this is our director room, and we have one toilet here. There is only one water closet. So as we did earlier, we can consider toilet near director room. We can consider only one water closet. It will consume like a 25 liter per second as a exhaust. So I have considered one. So 25 liter per second is the exhaust, and 23 liter per second is the fresh air. So the next one, we have one pantry near to the lobby. The same like what we did here. We have a very small pantry near to the lobby, like you see here. This is the lobby, and at this point, this is the pantry. So this one, as I told you, we have one small micro oven and coffee maker. So the same one kitchen we can follow. Pantry near lobby, and the same 1.5 liter per second we can follow. So the software will automatically find out the liter per second value, and it has considered the minimum value because the area is very low. And the next one is we have one washroom, male washroom, female washroom, and janitor room, the same location. So you can see here, this is the female washroom, 4-43, and this is the male washroom. And male washroom we have 4 water closets, so 4 into 25, 100 liter per second we can consider. So first one is the male washroom. I have considered 4 water closet, and female toilet we have 3 water closet. Like you see here, 3 water closet. So that I have considered here 3 water closet. So 75 liter per second will come, and 90% of the 75 I have considered the 68 is the fresh air. So here we have one common question that most of the time you might have seen that, as for example, let's say that we have this area 4 water closet, and we have one passage area here. So some people will consider the passage area also the ventilation from the ASHRAE 62.1. For example, if you go to this one, you can see this cell with the toilet. So this 5 liter per second for meter square, the people will consider for the passage area also sometime. But what I normally do is, this is a small area and we don't even have the urinal also. If there is any urinal, then we have to consider the exhaust properly for this passage area. This is the only wash basin area and it's a very small area. This is not a big public area. For example, we have the big mall. So the public area is a very big area. So that time we have to provide the exhaust. We have to consider the exhaust for this room also. This is a very small area. This area we don't need to provide the exhaust to follow that one. Because here what is the concept is, for example, if you provide the duct here, so you can drop the fresh air. You can drop the pressure at this point. So this exhaust, for example, let's say that 75 liter per second we have to throw the exhaust because of the 3 water closet. To compensate the exhaust, it will consider the fresh air from this area. So because we are dropping the fresh air at this point, so this fresh air will be circulated here. Okay, so for this small area we don't need to provide the exhaust. Similarly for this area also, this area is very small. Here we need 100 liter per second. So 100 liter per second, 90% of the 100 liter per second is the fresh air value. That fresh air, using the duct you can drop here by using 1 or 2 air terminals you can drop. So the fresh air will be taken outside, and to compensate the fresh air, the return air from this fresh air duct, it will terminal, it will manage. So we don't need to consider for the small area the exhaust. Okay, so if you have the big project and where is a big passage area, then for that one there is a reason you can consider the that area also. Sometimes you have the urinal, so urinal will be there at the corner, so that time you can consider the exhaust for that area also. Otherwise for the small area, no need to consider. So now that toilet room finish, we have only one janitor room here. Janitor room is 2 by 2, 4 meters square janitor room we have. So now here the last one is the janitor room here. So 4 meters square janitor room. Now for the janitor room we have to see the same ASHRAE to find out the answer. And if you go to the ASHRAE for the janitor room, you can see it is like 5 liter per second will be there. So you can see here janitor closet. So 5 liter per second per meter square. So in our case we have 4 meter square. So the software will automatically consider the value. Sorry, the Excel will automatically find out the value 20 liter per second, and we have to maintain the positive ventilation here. So it is 90% of the, sorry, here we have to maintain the negative ventilation. So 90% of the exhaust is a fresh air calculation, and it will be automatically duplicated. So finally for this entire floor we find out the answer here. So now we need to see how to make the air balancing, because that is one of the important step in the FHU calculation. So finally overall fresh air, it is coming like 765 liter per second is the overall fresh air for this area. And coming to the exhaust air, 755. So you can see here 755 here by 765, almost 0.987 percentage we have we will fresh air and exhaust. So the actual concept is we have to consider at least 10 percentage higher fresh air compared with the exhaust. For example, here the exhaust air is, let's say that you have the exhaust air that is 755 liter per second. So 10% minimum it should be higher. So 755 into 1.1, it is 830.5. So what we have now, we have is 765. So actually I need 830.5. So if you minus both, 835 minus 765. The answer is 65.5. So this additional air we have to consider, because I told you 10% higher minimum we have to consider. So this 65.5 additional we have to provide in the floor for the positive ventilation of the floor. In one floor we might have multiple negative ventilation. Like I showed here, in one floor there is toilet is a negative ventilation and kitchen negative ventilation, but overall floor must be positive. Overall project must be positive. In overall project there will be some rooms that might have the negative ventilation, but overall project must be positive. Then only the dust or dust particles will not come from outside to the building. So that is the key points. So to maintain that excess additional air, what we have to do is, so here we can see some common area like this corridor area and this corridor area, and here we have the reception lounge and this area. So this type of corridors area mostly we have in every project, and the reception we have in most of the project. So this additional 65 flow liter per second what we have, we can distribute and we can add with this corridor area and reception area, this shape of area. So the full flow will be positive ventilation. So that is the concept we have to follow for each project. The full floor and full project must be positive ventilation, but in one floor there might be some rooms that can be negative ventilation. That is not an issue. For example, here what will happen, I will add this positive ventilation in the corridor, I mean the extra ventilation in the corridor I will add here. So what we can do here, for example, let's say one concept wise, if you have toilet here, toilet, three toilets are there, toilet inside we have negative ventilation. So this to compensate the exhaust fresh air, here three toilets 75 liter per second is the exhaust. So we have to provide the fresh air to get the fresh air. It will take the additional air, the fresh air through the door undercut from the nearby area. Okay, so from this nearby corridor area it will take the fresh air, so it will be properly circulated and it will be compensated. So we can provide this additional fresh air to the corridor area, the reception area and different corridor area 65 liter per second. So the overall floor will be positive ventilator. Okay, so this concept we have to apply for the fresh air FASU calculation. The same method you can follow for the different flows, and overall project you have to provide the air balancing diagram, schematic diagram, so the reviewer can clearly understand what positive ventilation you have maintained. So finally, in our floor, the positive, the pressure should be 830.5 after adding the 10% higher, and the extras will be same. Okay, extras I am not going to make any changes. Extras will be same as it is 755, and positive is 10% higher of exhaust. Okay, then it is 831.5. Now I hope you are clear with this concept. In the next video I will explain you using this airflow, fresh airflow, exhaust flow, how to find out the total cooling capacity, how to find out the sensible cooling capacity using some shortcut Excel files. I hope this video is clear. If you have any doubts, please add your comments in the comment section. Thank you. Bye bye.